So don't lose it, please. Makes my life difficult if you lose it. It'll be okay. Find the equation in standard form and graph the ellipse with foci 0, -3, and 0, 3, whose minor axis has length 4. So we just reviewed the vocabulary. Minor axis, is that the wide side or the narrow side? The narrow. And it doesn't say semi-minor, it says the whole minor axis from vertex to vertex is 4. Okay, so let's talk about some things we know. What are things they give us that we know? We know the length of the minor axis is 4, but where does it start? Do we know that? How do we know it would be -2 to +2? Okay, but what if it went from 0 to +4? That would still be 4.
But then that would be the major.
We have to know where the center is. We can find the center from this information given. Okay, let's start looking at graph what we know. We know we have a foci at 1, 2, 3, -3. That's like our F1. It doesn't matter if it's F1 or F2. And +3. Okay? Because of symmetry, and we know the two foci, where's the center of the ellipse? 0, 0. Once you know the center, then we can find, we know the center is 0, 0. Then we can use symmetry and the length 4, and it just so happened Tassiano was right. What are our vertices? -2 to 2 along the... Oh, I graphed those points wrong, didn't I? What did I do wrong on my points? It's supposed to be the y-axis. Yep, I graphed them wrong. Because the foci should be in the middle, not on the outside of their vertices. So let's change that. Sorry. 1, 2, 3. Yes, that's better. 1, 2, 3. Okay, because then we know we have some vertices here at the minor axis is -2 to +2. How come I know the minor axis is on the x? Because the focal axis is the same thing as the major axis, right? The foci have to be on the major axis, which means perpendicular to that, the x's would have to be the minor axis. Okay, so this is our minor axis. I need some colors. You guys have those colored pencils on your desk? Why don't you pick like 2 colors and pass them down, because there's a lot of stuff here. From here to here, that's our minor axis. And with our minor axis, the semi-minor would be length 2. What label do we give to semi-minor? A, B, or C? B, that's our B. So now we know B is 2. Okay, this would be -B then, and that would be +B. A is the vertices on our major axis. But the foci is which letter? A, B, or C? F. A, B, or C. It's F. Well, yes, we use the labeling F. But with our Pythagorean relationship, it represents the C, because it can be plus and minus C. Okay, so we know our C is 3, right? So using our Pythagorean relationship, we can find A, which will tell us our vertices on the major axis for the long side of our ellipse. But let's go back to our list of vocabulary and look at the Pythagorean relationship because it's a little different. It's not a squared plus b squared equals c squared. What is it instead? Okay, so the a squared is isolated. So back to these notes. We know, maybe we'll put this over here. This is what we want. We know a squared equals b squared plus c squared. We're trying to find the other vertices along the major axis so we can draw the ellipse. We need the a. A is something we don't know. But we do know b is 2 and c is 3. So can you find a for me? What is a going to be? What's the exact value, not the rounded decimal? Okay, that's the rounded decimal because you would die before you finish saying that. Square root of 13 would be the exact value. The decimal would be helpful to graph, though. So when you do this, you should get 4 plus 9, which is 13, but that's a squared. So to get a, we would square root both sides, and we have a equals square root 13. That's the exact value. But for graphing, will you guys tell me that decimal you got again? About 3.6. Okay? So, and that is on our major axis, and it actually works because it's 3.6 past the foci at 3. Yeah, so it's just a little bit past it. That is our root 13, which equals a. And then also we have the negative version because it's plus and minus, right? When you take the square root. We have the, let's see, if this is negative 4, it'd be about right there. Negative a, which is negative root 13. And now we have all of our vertices. We can draw. Whoa, I missed that. Let's try drawing that again. Round it out so it looks like an ellipse. There you go. Okay, so it says find the equation. Oh, we need to do the equation too. And sketch. So we've done the sketch part. Now we should be able to write the equation since we found A, B, and C. I know it's been a long time, so you might need to look back at your notes. The equation of an ellipse looks like, gosh, it's even been a long time for me. That's right. Do we still have it over there? No. X minus h squared over a squared plus y minus k squared over b squared. And this is different than a circle. It doesn't equal a radius squared. It equals 1. So the circle equals radius squared, but the ellipse equals 1. So if our equation, h and k are the center of the circle, and we think opposite, but the center is 0. So do we need to put x minus 0 and y minus 0? No. So it's just x squared over, and look at the x-axis. What's the semi-minor's length? Semi-minor's length is length 2, but it'll be squared. So we write 4 plus y squared. The semi-major's length was root 13. What's root 13 squared? It's really easy. 13. Square root 13 times square root 13 times square root 13 equals square root 13 squared. Aren't squared and square roots inverses of each other and cancel each other out? So it's just 13 equals 1. That is the equation of our ellipse. Okay? Let's see. I guess we have one more on this, and then we'll move on to hyperbolas. Yay. Any questions on this problem before we continue on? Okay. Example 3, if you'd write that down, please. Find the standard form of the equation. So what we just boxed up as our answer for the last problem, that's standard form. Find the standard form of the equation whose major axis has endpoints. Whose major axis has endpoints -2, -1, and 8, -1. And whose minor axis has length 8. Then graph. Sometimes I think graphing first is easier than doing graphing second. Okay, the first thing you should start doing is deciding what you know, and then I like to put it on the graph so I can start visualizing what's going on. What do we know already? The what? Endpoints on which axis? The major. So we know the major endpoints are -2, -1, and 8, -1. So let's put those on a graph so we can start visualizing what's going on. Notice we have an x all the way out to 8, so that's going to be, actually, maybe I should put this down. So the tail end on the left would be kind of long. -2, we have a point. Oops, -2, -1. My bad. Yeah?
How do you know the major is the x-axis or the minor?
Well, we'll actually, sorry, I got distracted by the message. This one's different. But we do know that the major axis is wide. Okay? So let's plot 1, 2, 3, 4, 5, 6, 7, 8. How do I get rid of this? Just ignore? Bye. Okay. Okay. So these are our endpoints. This time, are they on the x-axis? No, because the center is no longer at the origin. So we only get it when the center is at the origin, with the major and minors be on the axes. In this case, does anyone know what the center is? If this is called the major axis. The chord connecting these is the major axis. What's the center? 3, -1? How do you find that out? The what? Halfway point. We find the midpoint. We have symmetry, right? So we find the midpoint. To find the midpoint, if it's not as easy as this one to eyeball, you just average. So the only thing that changes is the x's. The y's have the same height. They're both at height -1. So to find the midpoint, we're going to average. What does average mean? -2 and 8. What does that mean? How do we find an average if we have -2 and 8? Add them up, divide by 2. -2 plus 8, and divide by 2. So we'll need to do the numerator first. -2 plus 8 is 6. Divided by 2 is, in fact, 3. So the center, like she said, the x is 3, but what's the y? -1, because they all have to be on the same line. So all 3 of these points have the same height at -1. Any questions on how we found the center? This is the first time we've seen one that's not on the origin. Okay. So this was the not semi. This was the major axis. Okay, we have our endpoints. Do we know anything else that's given to us that that will help us find the graph and the equation? The minor axis has length 8. So then we should know the semi-minor. If the minor is 8, what's the semi-minor? 4. Length 4. Since we know the center, from the center, you just go up 4 and down 4. And then you have the endpoints. 1, 2, 3, 4. Straight down because it's perpendicular to the major axis. 1, 2, 3, 4. Straight up. And the semi-minor is which letter? A, B, or C? Semi-minor, is that A, B, or C? B. That's our B. Okay, so we have our ellipse. We have those endpoints now. What's the only thing missing from the graph of our ellipse? The what? Well, we can find the semi-major because we know the major is -2, -1, 8, -1. So while we're talking about the major, how long is the semi-major? How long was that from there to there? How long is that? 5. So that would be our A. So the semi-major we know is length 5, and we'll label it A. What are we missing? Foci. Which is C, right? If we know B and we know A, how do we find C? A squared equals B squared plus C squared. We use our Pythagorean relationship. Unfortunately, it's not exactly the Pythagorean theorem, but it's close. So we know A is 5 squared. And make sure A is on the major, that's good. Okay, and B is the minor axis, which is not 3, it's 4, huh? 4 squared plus C squared. Okay, you should be able to find the length from the center to the foci. This is not the point where the foci is, because we're not at 0, 0 anymore. It's the distance from the center along the major axis. Okay, stand up when you think you know C. Trying to find where I had it. Stand up when you think you know C. Oh, you have to go, huh? Okay, let's see here. Nope, not that one. Nope. Okay, Brandon, somewhere on here I have the homework. Now it's coming. Right here. Here's your homework, Brandon. But the homework is on ellipses. And you'll want to watch the video on hyperbolas, okay? H19, 2 through 30 even. Okay, stand up when you think you have C. This side is winning. We have one person on this side. What do we get? Okay, maybe you're too lazy to stand up. Fingers in the air. Can you raise your fingers? What'd you get, Kyler? 1? I don't think I got 1. Nope, I didn't get 1. You also got 1? No, you're just holding up a pinky. Okay. Okay, what'd you get? Okay, is it just 3 though? Because you take the square root, it's plus and minus 3. So go ahead and have a seat. You should have done 25 equals 16 plus C squared. Subtract the 16 over and got 9, right? And then you square root, but be careful. Plus and minus 3. Now, that's not, since we're not centered at 0, 0 anymore, it's not the actual coordinates of the foci. You start at the center, and you have to go along the major axis. Which one's the major axis? Horizontal or vertical in this case, because it changes. The wider side. Horizontal. So we go horizontally from the center to the left 3. 1, 2, 3. And to the right 3. 1, 2, 3. That's our foci, okay? That's from the center. Okay, now we can write the equation. Now remember there's some shifting, so I'll tell you these again. Remember, anything inside parentheses, we always think opposite. Okay, along the x-axis, we've gone to the right, how many? Where's the center shifted from the origin? To the right, how many? 3. But we think opposite because it's enclosed in parentheses, so we would write -3 squared. All over A, we already found A, didn't we? A was 5. Squaring it makes it 25. Who has questions on this first fraction? That's very detailed, huh? Now we do the y's, vertically. Yes. 5 is the length of the semi-major. Okay. Okay, so for the y, vertically, how many has it been shifted up or down from the origin? We're talking about the center. It's been down 1, which normally is -1, so we think opposite, +1. And you can even see that from the center. We already wrote the center was 3, so we wrote -3. Center was -1, so we wrote +1. And then the semi, let's see, this would be the minor. How long is that semi-minor? 4. So we square it and we get 16 equals 1. Make sure the x fraction has the horizontal semi-chord. And the y fraction has the vertical, because the y-axis is vertical, chord length. Okay? Your homework is just on the ellipses. We're going to talk about hyperbolas, but we don't have homework on hyperbolas today. Any questions about the ellipses before I show you the homework? After you write down your homework, then we can take a break. Okay, here's the homework on ellipses. H19, so it's in your honor section. We're going to be using the honor section for the next couple of days. I know. What? Yeah. For next class at least, because next class will still be on hyperbolas, so that's in the honors. And it's 2 through 30 even on ellipses. I believe there's graphing, so I will give you some graph paper after Kevin takes this picture.